In the previous section, we talked about authentication. The purpose of authenticating the user was so that we can have them upload music to our application. We won't be able to connect their uploads to their accounts if they don't have accounts to begin with. We want to be able to associate the songs with the uploader. With authentication taken care of, the next step is to take care of uploading the song. We're going to dedicate a page for uploading songs. Creating separate pages for different parts of your application is a common task. This process is what's referred to as routing. In this section, we're going to explore routing in Vue. Routing is a simple concept. A URL is mapped to a specific type of content. If you visit a URL for an image, the server will respond with an image. If you visit a URL for a blog post, the server will respond with a blog post, so on and so forth. Routing is a job that was typically handled on the server. Here's an example of what routing looks like in a traditional application. A user makes a request. The request can be to any page such as the home page or blog post. The server will use its router to determine what type of content to respond with. It isn't a new concept or specific to Vue. This sort of thing is handled on the back end with languages like PHP, Java, or Python. In recent years, JavaScript has matured into a powerful language. Browsers are becoming evergreen. Routing is something that can be handled on the front end thanks to the growth of JavaScript. It's a feature that's supported in most modern frameworks like Vue, Angular, or React. This isn't to say that routing is entirely handled on the front end. It's become a shared responsibility along with the back end. In this scenario, the user will see a blank page until the server responds with content. This behavior goes for any page visit. The problem with this approach is that the client will have to re-download the resources to render the content. Even if the rest of the page looks the same, this includes things like the logo, navigation menu, and footer. Routing on the front end is slightly different. Instead of loading a new page, the router will respond with a component. The component acts as the container for the content. Routers will allow us to configure which components to render for specific URLs. We'll be learning how to do that in a moment. After a component is loaded onto the page, we have the option of making a request to the server for data. In the previous example, the server handles rendering the entire page with the content. That changes in this scenario. Instead, the server will respond with data for the requested page. It won't respond with markup or stylings. It's plain data. Formatting and presenting the data is left to the front-end application. The component is what will render the template with the data. This flow provides a better user experience because the user never has to reload the whole page. Only individual sections of the page change. This behavior has another benefit. We save on bandwidth. Requesting an entire page comes with a lot of data to transmit. Data, by itself, is small compared to an entire page. By limiting requests to data, requests become faster. This reduction in size will lead to pages loading faster. A faster loading time is a better user experience overall. In the resource section of this lecture, I provide a link to the Vue Router documentation page. This package is the official router for Vue. By default, routing is not provided or configured for you. You need to install a module to get routing capabilities for your application. I want to make one point clear. You're not forced to use the Vue Router library as your routing solution. You may find that it isn't a suitable solution for your project. There are alternatives out there. For this course, we will be using the official router. It is the most popular solution and is updated frequently. Installing the Vue Router module is quite simple. You can run the command npm install Vue Router. We don't have to install the Vue Router module because it's already been installed for us. We selected it when we were scaffolding a project with the Vue UI. On top of installing the router, it was configured for us. Let's review the configuration in the next lecture. In this lecture, we're going to take the time to review the router configuration generated by the CLI. In your editor, open the main.js file inside the source directory. This file is where the configuration begins. The View Router module comes packaged in the form of a plugin. If you want to use it, you'll need to import it. At the top, with the other import statements, a file called router is being imported. We'll look at the contents of this file in a moment, but let's see where it's used. Down below, we're calling the use function. It's being passed in the router object. We can deduce that the settings are configured in a separate file for organization purposes. Let's open the router file next. It's the index.js file inside the router directory. Three things are being imported. The first two are the functions createRouter and createWebHistory. The third thing is the home component. The home component can be found inside the views directory. We'll look at it soon. We're going to ignore it at the moment. We want to focus on how the router is being configured. A variable called router is being defined. Its value is the object returned by the createRouter function. The object returned comes with methods, properties, and components that we can use in our application. This object gets exported in the file. It's the object that's being used to register a new plugin in the main.js file. This plugin will expose the methods and properties for interacting with the router. Back in the router configuration file, the function has one argument, which is an object of configuration settings. Let's go through them one by one. The first setting is the history. We can use this option to enable history mode in the browser. Most of the latest browsers come with an API called the History API. It lets you interact with the browser history. You can use it to change the URL in the address bar without having to refresh the page. The value for this must be an object with how we plan to use the History API to navigate the app. There are a lot of things we need to account for when using the History API. Luckily, the View Router library has a helper function for helping you generate the object. The value for this property is being set to the createWebHistory function. It'll take care of generating the object. It does require we pass in a base URL. This will represent the base URL for our application. The View Router library will take care of appending the URLs to the base URL. This feature saves us time from having to type out the full URL constantly. We can focus on the paths. In addition, it's important to set in case your application is inside a nested directory. Not all applications are hosted in the root document. For this project, we're using a property called import.meta.environment.baseURL. The import.meta object contains information on the current module. Through this object, we can access info on the current environment. That info can be accessed by looking inside the environment property. env is short for environment. We're accessing the base URL property. The base URL property can be configured through the Vite configuration file. In the resource section of this lecture, I provide a link to a documentation page with more info on this process. We don't have to change this since the default works fine for us already. Our server can be accessed by navigating to localhost. We don't have to worry about adding additional directories. The next property is the routes. This property will be an array of paths a user can access in our application. 2 routes have been created for our application. These are just examples to help you get started. We're going to create our routes from scratch. Empty the routes arrays. The home component isn't being used anymore. We can safely remove the import statement for it. I prefer to outsource my routes to a variable for better manageability. This step is optional. Above the router variable, define an empty array called routes. Next, update the configuration object with this variable. The last thing that happens in this file is the router object is exported. The exported object is what's registered in the Vue instance. This object will enable routing for the application. In the next set of lectures, we're going to begin creating some routes. In this lecture, we're going to create some routes. We'll be working on the router file we reviewed in the previous lecture. The routes are outsourced in a variable called routes. This array is what we'll want to modify if we're going to add some routes. The view router expects this array to be an array of objects. Each object represents a route. In the documentation, each object is referred to as a route record. We'll add a new route record to the array. The first route we'll create will be a route for the home page. We previously cleared the array, which removed the route for the home page. This empty array will leave our app broken for a moment. We'll want to add it back in. The first property we'll add is called path. The value for this must be a string. The path property represents the part of the URL after the domain. Let's say you had a domain called example.com. If you set the path property to /about, then this is the record that will be used if anyone visits the URL example.com/about. For our first route, we'll be creating one for the home page. We'll set this to a / character. The next property we'll need to set is the component property. Whenever a user visits the application, the router will retrieve the path from the URL. It'll try to match the path with the records we've registered. If it finds a match, it'll load the component related to the record. We can set the component with the component property. The value for this must be the component object. For the past few sections, we've been creating components in the components directory. There's another directory for components called views. This directory is where you define components that will act as the container for the page's content. It's common practice to store generic components in the components directory. Components that will render the page's main content should be placed in the views directory. Let's open this directory. We'll find two components called home and about. In an earlier lecture, we cleared out the home component. We're going to use this component to render the content for the home page. The great thing about using the router is we don't have to change anything about how we create components. Components are still made up of the template, script, and style blocks. We have access to the same lifecycle functions. The only difference is where we define our components. This structure is to keep things organized. Let's begin loading the component for the record. In the router file, we're going to import the home component. I'm using the @ symbol to point to the source directory. This shortcut makes it easier to import the component without having to guess where we are. Next, we have to set the component property for the home record to the component we imported. Voila! We've created our first route. Now whenever a user visits this path, the view router will render this component onto the page. Let's try creating another route as an exercise. We'll create another route record for the About page. Inside the Views directory, View has provided us with an About component. We might as well use it. Open the About component. We're going to leave it with a basic template. There shouldn't be any script or style blocks. Next, let's go back to the router file. We'll create another record in the array. Inside the record, we'll set the path property to /about. Then, we'll set the component property to the About component. The About component isn't available. We'll need to import it. We're finished adding routes. We'll add more routes later in the course. Before we view the front end, let's adjust the content in the home component file. Open it in your editor. We'll add the template block. The content for this component can be found inside the app component. It's the root component of the application. The app component's template is based on the index.html static file. It's where the homepage content is placed. We'll want to move the sections that will act as the main content. We've taken care of moving the header and authentication sections into separate components. This will leave us with the introduction, main content, and player sections. The player is something we'll put into a separate component. The other two sections will be used for the main content. We'll cut both sections from the app component. Then, we'll paste them into the template block of the home component. We'll leave the component with static content. The purpose of adding content is to check if the router is working by rendering different content based on the URL. The very last thing we'll need to do is to tell the router where to display the content. It won't magically guess where it should display the content. It also won't replace the entire document with the component. That's a good thing because we won't have to load the header or authentication components repeatedly. It's our job to instruct the router where to load the content. Let's switch to the app component. We're going to want to load the content where we previously removed it. Below the app header component, load the component router view. The View Router plugin registers this component. It was defined when we registered the View Router module as a plugin. It's a global component. We don't need to do anything else to get this to work. The View Router will automatically know which component to load based on the route records we created in the router. This component will be replaced with the correct component associated with the path. Let's test the application in the browser. The page will continue to render normally. It'll look the same. We'll find the introduction message along with the list of songs. Let's inspect the console for errors. The router is working like we wanted. The question is, do the other routes in our application work? We'll look at how we can view other pages by discussing the history mode in the next lecture. In this lecture, we're going to look at how the history mode can be used to change how URLs work in our application. Currently, we don't have links to navigate around. If we want to test the router properly without links, we'll need to switch the mode. I'll explain what's going on in a moment, but first, let's change the mode. We'll continue working in the router configuration file. We're going to change the import statement to grab the create web hash history function. Then, we'll update the history property to this function. The arguments will remain the same. I'll break down what's going on, but let's see its effects in the app. Back in the browser, refresh the page. Everything's still the same except for the URL. In the address bar, the View Router library has added a hash to the URL. Very mysterious. Let's try testing if the /about path works. Before we do, switch to the network panel. We want to check that the page does not refresh. It shouldn't because the View Router will prevent that. We should be able to switch between pages without having to re-download assets. If there's already logs in the network panel, you can clear it by pressing the Clear button. Without removing the hash, add the word about to the URL. The message inside the About component will appear. The network panel won't log anything new. This means that even though the URL has changed, the page didn't refresh. Instead, the router was able to change the content without having to reload the assets internally. We can view more information about the routes by switching to the View Developer Tools. There's a section called Timeline. On the timeline, we'll be able to view events. The history will provide you with a log of paths that have been accessed in the application. If I were to press the backward or forwards button on the browser, new paths would be logged. This logging capability is one of the benefits of using the View Router. It integrates perfectly with the View Developer Tools. All this information is available to help us debug the application. I can even click on each path to see more details. We won't be diving too deep into this. We'll be exploring it in future lectures. There's another section called Routes. It'll contain a list of routes registered in our app. It'll tell you which route is currently active. You can click on a route to view the details. We won't find much information because we're keeping our routes simple. This tool is a great way to check if your routes were registered successfully without moving around in your application. This is the basics of routing. The minimum requirements for creating a route is to set the path and component. The router will take care of the rest for you. We've covered the basics. Let's talk about the hash you'll find in the address bar. To better understand what this does, I'm going to switch over to Wikipedia. I'm on the page for pizza, but any Wikipedia entry will do. Every Wikipedia page has a list of contents. There are links to sections on the page. If you can click on any of these list items, you'll automatically jump to that section of the page. This is performed with basic HTML. JavaScript is not required to perform this trick. Creating this effect isn't hard to pull off. The first step is to assign an ID to an element. After assigning an ID, you can create a link that points to that element by using a hash. I'm going to scroll back to the list of contents. I'll inspect one of the links. In the developer tools, we can clearly see that the href attribute is set to the section's ID. Browsers will interpret this differently than full HTTP URLs. Instead of reloading the page, it'll jump to the section. This is what the Vue router is using because jumping to a section doesn't cause the page to refresh. The router will override this behavior by swapping out components. You may be curious as to why the router opts to use the hashing system. This is because the hash system has been around longer than most web APIs. It's a system that even works in legacy browsers. If you're building an application that must work on older browsers, then you may want this behavior. The problem with using hashes is that they don't get indexed by most search engines. Another issue is that users don't commonly type hashes in their address bars. Luckily, a new API was introduced to solve this issue called the History API. In the resource section of this lecture, I provide a link to a site that goes over how to use the History API. We don't have to worry about the details of how the History API works, because the router library will take care of it for us. Let's go back to the editor. Previously, we switched the functions around. We're going to change the function back to the Create Web History function. The Vue router will switch to using the History API. There's another mode available called Memory. This mode is when you want to keep the route changes tracked internally without modifying the URL bar. It's not a common mode to use, but it is available if you ever need it. The History mode will suffice for now. Save your changes and view the browser. Everything will continue to work. Let's try changing the path to something else. The application will continue to render the component associated with the record. This behavior is fine, but there are a couple of things you should be aware of. First is that the page gets reloaded. If we were to view the network panel, clear it out, and then change the path, this would result in a page refresh. This isn't an issue with Vue or even JavaScript. This behavior is how browsers are supposed to behave. Anytime a change is made to the URL in the address, the browser will force a new request. Otherwise, it would be hard to navigate around the web. Previously, when we used hashes, this wasn't the case. It's because browsers are smart enough to know that anything after a hash relates to the content on the page and not some other location. If we want to navigate from page to page without reloading assets, we'll need to add links. That's perfectly fine anyway. Users don't normally browse a site by constantly changing the URL in the address bar. They navigate around by clicking on links. We'll learn how to create links in the next lecture. The very last thing I want to mention is how pages are delivered to the client. Servers will always have priority for handling requests. Vue is a client-side library. It will not run until the application is delivered to the client. Therefore, it's always important to respond with an index.html file regardless of the URL. Just because we make a request to the About page doesn't mean the Vue router will automatically handle it. Servers always get first dibs on stuff like this. After the index file is delivered, our application can take over routing and display the correct content. We don't have to worry about doing that because we're using Vite to create a server. Vite will always serve the index file. If you're using a different backend, then you will need to configure this yourself, or you can have a backend developer handle it. In the resource section of this lecture, I provide a link to the history mode documentation page. As stated on the page, simply changing the mode to history won't automatically make routing work. There are example configurations you can make to the backend to get this to work fully. It depends on what you're using as the server. I'm mentioning this now because you may want to test this on a production server. Things may not work as expected. Just remember to serve the index file so that Vue can handle the routing. I recommend reading the page further if you're curious about how the History API works in Vue. In this lecture, we're going to learn how to create links to navigate around. We don't want the user to navigate around by manually typing in the URL in the address bar. We will provide links to the pages we want them to have access to. We'll start by making the links in the menu on the header functional. We'll be working in the header component file. Inside the template, we have an unordered list of links. We want to stop the default behavior for when a link is clicked. We don't want the browser to make a request causing the browser to refresh. Instead, we want to check if the link matches any of the paths we set in the router. If there's a match, we want to redirect the user without having the browser reload the assets. The router library provides a component that will handle the heavy lifting for us. We're going to start by creating a link to the home page. Up above, there's an anchor tag with a comment that says app name. Instead of using an anchor tag, we're going to replace this with a component called router link. This component is a global component registered by the Vue Router plugin. The router link component will create an anchor tag. The main difference is that the anchor tag will be listening for click events. If a click is detected, the default behavior will be overridden. The router will handle the redirect rather than the browser. We can leave the class attribute alone. It'll get applied to the anchor element created by the component. We're going to modify the href attribute. Then we'll change the name to 2. This is a property where we can set the path to redirect to. We have the option of adding in a / before the path. If we do add a /, the router will append the path to the domain. Otherwise, it'll append the path to the current path. For example, let's say I set this to about. If the current URL is example.com, then the user will be redirected to example.com/about. However, if the current URL was example.com/test/test, then they would be redirected to example.com/test/about. This is fine if that's what you're aiming for. However, if the URL you meant to redirect them to was example.com/about, then you should add the / before the path. Let's test if this is true. Even though this is the home link, we'll be setting the path to about for example purposes. Open the app in your browser. Before we click on the link, let's inspect it in the developer tools. The router link component will be placed with the anchor element. The href attribute is set to the path we passed in. You may see a / prepended to it. This is fine because the router library needs the full path relative to the URL. The class attribute has the classes we added to the component. Additional classes are being added, which we can use to stylize the link. We'll be doing that soon, but for now, we're going to ignore them. The router library doesn't load CSS code into our app. We don't have to worry about them. Lastly, the text inside the anchor tags is the same text placed inside the component. In a way, the router link component is almost like the anchor element. The main difference is that it'll attach some event listeners to the anchor element. This is for handling the redirect. Let's give things a test by clicking on the link. After clicking on it, almost instantly, the main content switches from the home component to the about component. The browser didn't have to reload the contents. Vue takes care of making the changes. We can verify this by switching to the Vue developer tools. Under the router history section, we'll find the logs for the path changes. This log proves that the components were swapped with one another. This works as expected, but there is an issue with this implementation. Inside the URL bar, I'm going to change the path to test/test. If the path does not match any of the records, the router will not render anything at all. This is not what we want. We can override this behavior by creating a 404 page, but we'll get to that in another lecture. For now, I'm going to click on the link again. This time the router will navigate to test/about. This behavior isn't what we want. We want to redirect the user to the /about path. If you do not add a /, the path will get appended to the current path. It won't redirect based on the path relative to the base domain. We can resolve this by always adding a / to the path. Back in the editor, update the to property with the / character before the path. Let's test this again. Starting from a nested path, I'll click on the link again. The browser will take us to the /about path. By adding the / character, we're assured that the path will get appended to the domain rather than the current path. I wanted to highlight this as you may forget to add the / character from time to time. I know I have. In the next lecture, we'll work on creating links for the other pages in our app. In this lecture, we're going to add links for the other pages in our app. Now that we know how to create links, let's add more links in the header. We'll continue working in the header component file. Previously, we updated the link for the home page to point to the About page. We're going to change the link to point to the home page by setting the to property to a /. We don't want to link this to the About page. That was just an example. However, we don't want the About page to go to waste. We'll create a link for it. It's an excellent opportunity to practice creating links. Let's scroll to the unordered list of links in the template. At the very start of it, we'll add a new list item. It's going to have a similar HTML structure to the rest of the links. Next, we'll change the anchor element to the router link component. The href attribute will be changed to the to property. The path will be /about. Lastly, the inner text will say about. There are additional links in the navigation menu, but we'll update them when we create pages for them. At the moment, we have 2 pages. We're going to create one more link. In the unordered list of links, there will be a link to a page called Manage. In the next section, we're going to begin handling music uploads. The Manage page will allow authenticated users to upload and edit their songs. Even though we won't make the page functional in this section, we'll start by adding a link to it. We'll change the anchor element to the router link component. Next, we'll change the href attribute to the to property. The path will be set to /manage. The route currently doesn't exist, so we'll need to add it. Switch to the router file. We'll add a new record to the routes array. We'll set the path property to /manage. We'll need to create the component for this route. Inside the views directory, create a component called manage. It's not required to define the component in this directory. The views directory was created to organize components that are meant to render the main content for the application. In contrast, the components directory is meant for generic components. We could put everything into one directory, but I like this organization structure. We'll add the template block to the newly created component. Unlike the About component, I don't want to add dummy content to the Manage component. I've gone ahead with providing a static template for this component. You can find it by opening the manage.html file. It's one of the templates I provided along with the assets. We downloaded this file in an earlier section. I'm going to fold some of the code to make it more readable. The section we want to copy over is the section element with the class container main. Above it, there's a comment that says main content. We're going to copy everything inside this tag. Then, we'll paste it over to the Manage Components template block. You may need to format the code upon pasting it in. It's a big template. Don't be intimidated. I'm going to break down every section as the course progresses. By the time we're finished, it'll be fully functional. The Manage component is ready. We'll need to update the route to use this component. Back in the router file, we'll import the Manage component. After importing it, set the component property to the Manage component. We're finished. Let's give the application a test in the browser. You may not see the link to the Manage page because we've limited its visibility to authenticated users only. If you're not logged in, do so now. After logging in, we'll see the link. Try clicking on it. We'll be redirected to a new page. This is the UI we'll be using for the Manage page. On the left, we have a Dropbox for uploading songs. This Dropbox will initiate an upload process. During the upload process, we'll display a progress bar to show the progress of their upload. On the right, we'll find a list of songs uploaded. The user has the option of editing or deleting their songs. If they edit a song, then a form will appear with the relevant settings for that song. They will be able to change the title and genre. We will be making this page functional in the future. There are additional topics for routing I want to discuss before we get to it. In this lecture, we're going to add styles to our active links. A link is active if the URL in the browser matches the URL in an anchor tag. The View router allows us to change the appearance of a link if it's active. It's a great way to let the user know they're on the right page. Creating active links is an optional step for most applications. I recommend creating active links because they're a subtle way to improve user experience. They let the user know where they're currently at in the application. Let's begin creating some active links. We're using the Tailwind framework. We need to pick a class for changing the color of the links if they're active. I've gone ahead with picking a class. We're going to be using the Text Yellow 500 class, which will change the color of the link to yellow. We should apply this class to the anchor element if the link is active. Let me show you what the link will look like after applying it to the class. I'm going to inspect the About link on the menu. On the anchor tag, we're going to swap the Text White class with the Text Yellow 500 class. Immediately, the text will turn yellow. We're going to use the View router to toggle the Text Yellow 500 class on the links. If we look closely at the link, there are additional classes added to the anchor element aside from our Tailwind classes. These classes are applied by the router link component. There are different ways we can customize this behavior to get the desired effect. The simplest way is by overriding the class names. We can swap these classes with our own classes. In our editor, let's open the router file. Scroll down to the router variable. The object being passed into the createRouter function is where we can configure the router. We can configure the classes that get applied to active links in this object. There are two classes added by the router. The router will perform partial and exact matching. First, it'll check for a partial match. A partial match is when the URL and path don't match completely, but if the URL does contain the path, then an active class will get applied. This is great if you have a submenu navigation, but we don't have one in this example. It doesn't make sense to have the active class applied to the link. The second type of matching is an exact match. If the path and URL match exactly, an active class will be applied. We need to ask ourselves which classes we want to override. For our case, we will be overriding an exact match. There isn't a reason to highlight the link if there's a partial match. In the configuration object, we'll add an option called Link Exact Active Class. This value for this option must be the name of the class we'd like to use. We'll set this option to the text yellow 500 class. We're finished. Let's refresh the page in the browser. If we navigate to the About page, the About link is highlighted in yellow. This indicates the text yellow 500 class was applied to the link. If we navigate away from the About page, the link will turn back to white. There's only one problem. The link to the home page turns yellow. It looks awkward and unnecessary. We want other links to change color except for the name of our app. Luckily, the router package allows us to override the classes on a specific link. We don't have to apply the classes globally. Back in the editor, open the header component file. Search for the link to the home page. There's a comment above it that says App Name. We're going to add a property called ExactActiveClass. The value for this property will be the class name that gets applied to the link when there's an exact match. The router library will prioritize this class over the global class. We're going to set this property to NoActive. The NoActive class doesn't exist in our app. We're adding it in to prevent the link from turning yellow. We're using this name to help other developers understand the color of this link shouldn't change. Let's refresh the page. The link for the home page has turned back to white. If we navigate around, the other links will turn yellow. We've achieved the desired effect. If you would like more information, you can check out the documentation. In the resource section of this lecture, I provide a link to the API reference documentation page. Be sure to check it out once you're finished with this section. In this lecture, we're going to learn how to assign names to our routes. Throughout the development and lifetime of an application, you may find yourself changing the path for some of your routes. This can be for a variety of reasons, such as SEO or wanting a better structure. Whatever your reason may be, you will have to go to each component to update the links accordingly. Updating links in every component isn't scalable, especially if you have hundreds of them. A better way to create URLs in the application is by using named routes. Routes can be assigned names to reference them in other parts of your application. They can even be used to generate URLs. Adding a name to your route is quite simple. Inside the router file, we're going to add a property to the home route called name. This property will allow you to assign a name to the route record. I recommend using a short and relevant name. For this route, we'll give it the name home. Let's assign names to the other routes too. A route with a name can be referenced by its name rather than its path. We're going to update the links in the app to use the names instead of the path. Open the header component file. We'll start with the link for the home page. To use the name instead of the path, we'll need to update the to property in the router link component. We're going to bind it. The to property can be set to a string or an object. If we pass in a string, it'll expect the value to be a path. An object will allow us to instruct the component to use the name instead of a path. We'll pass in an object with the property name. The name property must be set to the name of the record. The name of the path for the home page is home. The router link component will generate a link to the home page. It'll search through the records to find a name that matches the name we set in the object. If it finds a match, it'll use the path assigned to that route. In addition to the name property, you can also add the path property. This property will let you set the path in an object. It's the same as what we had initially. However, by binding the property, you can have dynamic and complex values. There are some cases where you'll want to set additional values, such as query parameters. We're going to explore what those are in a future lecture. We're not going to add the path property. Names are much more scalable than using paths for creating links. In some scenarios, you may want to change the structure of your URLs. Anytime you make a change to the path, you will have to update the link in every component file that uses the same path. If you're using the name, you won't have to worry about this. You can change the path as many times as you'd like. The changes are reflected on all links as long as they're using the name, thus giving you more freedom and flexibility. Another reason for using names is that it makes your links more readable. You may have paths that are long. You can save yourself time from having to type a long path by using its name. Let's test if this works. Open the app in your browser. I'm currently on the About page. If I were to click the Home link, then I'll be navigated to the Home page. Even though I'm not using the path, the router will still be able to create a link to the home page based on the name we set in the object. Here's an exercise before we move on to the next lecture. Try updating all the links we've created so far to use the name rather than directly inputting the path. The process should still be the same. We've already given the routes names. The last thing to do is to update the router link components to use the names instead of the paths. Good luck, and see you in the next lecture. In this lecture, we're going to look at an alternative solution to the problem we faced in the last lecture. The issue I'm talking about is the 404 error the user may receive if they visit a path that has been changed. Let's look at the router file. In our array of routes, we have one record for rendering the page for managing music. We have another record that redirects the user from the old path to the new path. This is how we resolved the issue. If we change paths, we should always make sure to redirect the user from the old path to the new path if they attempt to visit the old path directly. There's another solution we can implement to solve this issue. We can use an alias. I'm going to comment out the record that redirects the user from the old path to the new path. An alias is an additional path that renders the same component. We can add an alias to the record that renders the component. We're going to add the alias property to the Manage Music route. The value for this will be a path. We'll set this property to the old path, which was manage. Here's what will happen. If the user visits either the Manage Music or Manage paths, the router will render the Manage component. You can think of the alias as an additional path for the component. Let's visit the Manage page using the alias path. The Manage component is rendering. The path in the URL hasn't changed. This is one important distinction to make compared to the previous solution. The previous solution would redirect the user if they visited the old path. The current solution will allow a component to be rendered for a different path. The user is not being redirected. This can be useful in case you don't want to perform a redirect. We're going to continue using the previous solution. Back in the editor, I'm going to comment out the alias property. Then, I'll uncomment the redirect record. I prefer redirects over aliases because it's better for search engines to index the new URL as fast as possible. It can hurt in the short term, but I believe in the long term it'll be beneficial to let search engines be aware of the URL structure changes. I'll leave it at that. We'll continue working on our app in the next lecture. In this lecture, we're going to discuss how to protect routes with navigation guards. Protecting your routes means preventing users from accessing a route if they don't have the proper permissions. In the resource section of this lecture, I provide a link to the Navigation Guards documentation page. This page goes over in detail how to guard routes. The term guard refers to the ability to perform checks on a request before rendering a component. Guards are defined as functions. In this case, we can run a function before a user navigates to a specific page. We're essentially guarding a page. Let's go over how this is done. In our application, we have a page called Manage. It's accessible if the user is logged in. If the user isn't logged in, they won't be able to see the link to the Manage page. However, the page is still accessible if the user visits the URL directly. Inside the address bar, I'll visit the Manage page while I'm logged out. I'm still able to access the page even though I'm logged out. This shouldn't happen because we want the user to be logged in order to upload and manage their music. To prevent this page from being accessed by unauthenticated users, we're going to want to check their authentication status. If they're authenticated, we'll let them access the page. The View router provides us with 3 options for tackling this. We'll go through them all. The first option is a global guard. It's a guard that will run on every route. In your editor, open the router file. After defining the router variable, we're going to call the beforeEach function. The beforeEach function is available after the instance of the router is created. It'll allow you to run a function before every request. This guard applies to all routes registered in our application. This allows us to perform checks on the user or anything else. We can do whatever we want. It has one argument, which is a callback function it can call whenever a request is made. We'll pass in an arrow function. The callback function can accept in 3 parameters. They're the to, from, and next parameters. We'll accept them in our callback function. The to parameter is an object that contains information about where the user is navigating to. Vice versa, the from parameter is an object that contains information about where the user is navigating from. The next parameter is a function. This parameter is the most important one. The router will not render the component until you've called this function. If this function is never called, the component will never load. In theory, if you want to stop a user from accessing a page, then you should never call this function. Before we write the logic, let's log the to and from parameters. We're going to log the parameters because we want to check if the global guard works. In another log statement, we're going to log a message to tell us this is coming from the global guard. Lastly, we'll call the next function because we don't want to block the component from rendering. Save your changes, then head over to the browser and check the console. The guard function was called because the log statements are appearing in the console. The guard function runs on every request, including the initial one. There are 2 objects logged in the console. The global guard is working as expected. Before we move on, I want to note that the parameters we're logging can be found in the View Developer Tools. In some situations, you may want to log the object yourself instead of using the developer tools. The difference between the two is that the console may log more information. For example, in any of the objects in the console, we'll find a property called hash. The hash property represents the value after the hash character in the URL. The View Developer Tools will usually not bother to display data if it's empty, so you shouldn't think that you're missing out on anything. It's normal. If we were to navigate around the application, the global guard is constantly called on every request. This is indicated by the logs in the console. It's great if you want to perform checks on every route request. For our case, it's excessive because we want to prevent visitors from accessing pages that require authentication. If a page doesn't need to perform this check, then we don't need to perform it to begin with. We'll look at how we can apply guards to specific routes in the next lecture. In this lecture, we're going to look at how we can apply guards to specific routes. The first option we have for applying guards is a global guard. This may be great if you want to perform checks on every route. For our case, it's excessive. That brings us to the second option. We can add guards to specific routes. Back in the editor, we're going to remove the console statement for the to and from parameters in the global guard. We're removing them because we don't need to log the parameters anymore. The View Developer Tools will log the information for us anyway. I prefer to use it over manually logging the parameters. we are going to leave the message in the function for example purposes. A route guard can be applied to a specific route by defining the before enter property on the record. We're going to add this property to the manage record. The value for this must be a function. We're going to use an arrow function. Just like the global guard, we're going to use the same three parameters. They're the to, from, and next parameters. Inside the function, we're going to log a message to let us know the guard is working. Afterward, we'll call the next function to let the router render the component. The main benefit of defining a guard on the record is that the guard will run when the route is visited. Let's give things a test. In the browser, load the home page in the app. If you haven't already, log in. After logging in, navigate to the Manage page. Inside the console, there are a total of 3 logs from the guard functions. The first 2 are from the global guard, one for the home page and another for the manage page. The third log is coming from the guard for the manage record. The guard will never run unless the route is visited. Let's explore the final option for defining a guard. You can define guards in components. You don't have to keep defining them in the router file. Back in the editor, open the Manage component file. The first thing we'll need to do is add the script block. Inside the script block, export an object. Add the name property to the exported object. We're going to give it the name Manage. Inside the exported object, we're going to define a method called beforeRouteEnter. If this method is present in the component, the router will run it before rendering the component. Like the previous guard functions, we have access to the to, from, and next parameters. We'll accept them in the function. Inside the function, we'll log a message to let us know when the guard runs. Then we'll call the next function. Alright, let's preview this. Refresh the page in the browser. Everything still works because we're calling the next function. It's very important to call the next function so that the router will render the component. Otherwise, we'll be greeted with a blank page. Inside the console, we'll find messages from all 3 guards. One thing I want to point out is the order of the messages. If I were to refresh the page, the order is always the same. This is not a mistake. Guards run in a very specific order. Go back to the documentation page I talked about earlier. Scroll to the very bottom. We'll come across a section called the resolution flow. This part of the documentation talks about the order the guard functions will run. There's more that goes on than what we've talked about before. The router provides a variety of ways to run code during a navigation event. This order may be important to know if you have multiple guards applied to the same route. Now the question is, which guard should we use? Generally, global guards are great if you want to run some code before every request. Otherwise, I recommend using the more specific guard functions. Either one works. It's all preference. I prefer to define my guards in components. This reduces clutter in the router file. In the next lecture, we'll take the knowledge we learned to restrict access to the Manage page. In this lecture, we're going to prevent access to the Manage page if the user is not logged in. There is one limitation with guards that we'll need to learn before we can guard the route. Guard functions do not have access to the methods and properties of a component. This includes the beforeRouteEnter guard. The this keyword is unusable. This is because the component hasn't been rendered or initialized yet. The navigation guards run before any of the lifecycle functions do. It isn't until we call the next function that the component will be created. It's important to understand this because you may want to access the data in a component, but won't be able to until the guard calls the next function. Unfortunately, this includes the store. we'll continue working in the Manage Component file. We'll need an alternative method for accessing the state. Luckily, mapping the store to a component is an optional step. For emergencies, we can run the store as a function. This will cause the store to return an object with access to the state, getters, and actions. At the top of the script block, import the user store. If we want to access the store in a guard, we'll need to import it directly. Inside the BeforeRouteEnter function, create a variable called store. Its value will be the useUserStore function. We're going to check if the user is logged in the navigation guard. Remove the next function. We want to perform some checks before calling the next function. Let's create a conditional statement. For the condition, let's check the store.userLoggedIn property. If it is, we'll call the next function. If they aren't, we'll want to redirect them. We'll add an else block. The next function can be used to redirect the visitor. We can pass in a string of the path we'd like to redirect them to. Alternatively, we can pass in an object for a more complex path. It's the same object you would use for the to property on the router link component. We're going to use an object because we want the router to use the name of the path. We'll pass in an object with the name property set to home. Another option is to pass in false. This value will prevent the component from loading. It's the same as not calling the function at all. However, I don't want to show the user an empty page. I would rather redirect them. Let's try testing if this works. Let's refresh the Manage page in the browser. The page will load properly because I'm logged in. I'm going to log out. Then I'll refresh the Manage page. This time we're redirected to the home page. By using a navigation guard, we're able to deny access to pages where a user doesn't have the correct permissions. We'll look at ways we can improve this in the next few lectures. In this lecture, we're going to redirect the user if they log out. We're able to redirect the user if they're not authenticated by using navigation guards. One scenario we haven't accounted for is when the user logs out of the application. I'm currently logged in viewing the Manage page. If I log out, the user logged in state property is set to false. This update is reflected in the navigation menu. However, I'm still able to view the Manage page unless I navigate away or refresh the page. It would make sense to navigate the user away from pages that require them to be authenticated. Navigation guards won't be able to help us because they get executed when the route changes. We'll have to take a different approach if we want to redirect them. Open the header component inside your editor. In the script block, we're mapping the user store. The sign out action is what takes care of logging the user out from the application. When the user clicks on the logout link, we'll want to run this action along with redirecting the user. We can accomplish this by redirecting the user after they log out. To get started, let's modify the original solution for logging the user out. Inside the Methods object, define a function called SignOut. Inside this function, we're going to run the SignOut action, which is accessible via the this.userStore object. We can execute action functions directly from the store object. Next, we'll redirect the user to the home page. Fortunately for us, we have access to the component's methods and properties. View will inject the router instance into every component. We can use it to redirect the user. We can access the router object through the this keyword. The method for redirecting the user is the push method. You have the option of passing in a string or an object. We'll pass in an object with the name property set to home. It's called push because that's what we're essentially doing. We're pushing the next path on top of the already visited paths. Keep in mind that we're using the History API. It keeps track of the paths the user has visited. This API allows the user to go back and forth between pages without having to refresh the page. This will work, but it isn't the ideal solution yet. The user should only be redirected if they're on a page that requires authentication. The question is, how do we know which route the user is on? Above the push function, we're going to log the $route object. The $route property will be an object of the current route. While not necessary, I'm logging the current route before the redirect so that we don't always see the same route information. Before moving forward, scroll to the template. The logout link must be modified. On the click event, change the expression to the signout method. Save your changes, log in, and navigate to the Manage page. Make sure the console is opened in the Developer Tools. If we press Logout, we'll be logged out and redirected to the home page. We're able to get the behavior we want so far. Inside the console, an object representing the previous route was logged. The property we care about is the name. We'll use this property to identify the route. You may also use the path, but I prefer to use names because they're more consistent. Back in the editor, we're going to comment out the console statement. Afterward, we'll surround the push function with a conditional block. We'll want to check if the route.name property is equal to manage. This condition will assure us that if the user logs out while on the manage page, they will be redirected. Any other page, they will be able to stay on it. Let's give things a test. I'll quickly log in and revisit the manage page. This time if we log out, we're redirected to the home page. Great. We've successfully solved the issue we had earlier. Redirecting the user is as simple as calling the push function. In the guards, we didn't have access to the router object, so that's why we had to use the next function instead. In most cases, you will generally want to use the router object to redirect the user. In this lecture, we're going to utilize metafields to improve the redirect behavior we implemented in the previous lecture. Currently, I'm looking at the signout method in the header component. We programmed the app to redirect the user if they attempt to visit a restricted page while they're not logged in. In the conditional statement, we're checking what the current route is before redirecting them. This solution works if we're working on a small-sized app, but it doesn't scale for large apps. You may have dozens of routes where the user must be authenticated to navigate to it. If that's the case, we'll have to update the conditional statement with the routes. Here is what it would look like. I've updated the conditional statement to check for 5 different routes. These routes don't exist. You don't have to make the same changes. This is just an example. As you can see, it's starting to look unpleasant. Just imagine what this would look like if we had 20 routes or even 200. This solution works, but it's not elegant. I'll undo this quickly. We can improve upon this by using route metafields. In the resource section of this lecture, I provide a link to the route metafields documentation page. Metafields are custom values that can be assigned to your routes. They can hold any type of data, a string, object, number, etc. By giving our route a metafield, we can check for the metafield rather than the name. Using metafields is quite simple. Let's get started. The first step is to add the metafield to the record. Open the router file in your editor. We'll add a metafield to the Manage Route record. In the record, add a property called meta. The value for this must be an object. The object can contain a set of key value pairs. We can store any type of data in this object. We're going to create one property called requires_auth. We'll set it to true. We'll use this to determine whether a route requires authentication. We won't be adding it to the rest of the routes because it's not necessary. We'll assume that if the meta field doesn't exist, then the route doesn't require authentication. The next step is to check for the meta field. We'll switch to the header component file. Search for the signout method. This method is where we redirected the user. Inside the conditional statement, rather than checking for the name, we'll check the meta.requiresAuth property. We want to check if it's true. The meta object is available on every record. It'll hold the meta fields we added to the record. If the requiresAuth property exists and is true, then we'll redirect the user. We can take this even further by checking the meta field on every request. Open the Manage component in the editor. We used the before route enter guard to check if the user was authenticated. It works, but it only works for this component. If we had another component that requires authentication, we would have to copy and paste this solution. It's not exactly ideal at the moment. With the introduction of metafields, we can check for the metafield on a global level rather than in the component itself. Let's adjust this code using metafields. First, we'll need to remove the guard from the component. It doesn't make sense to keep it around if we're moving things on a global level. I'm going to comment out the guard as well as the import statement for the store. I'm commenting out the code rather than removing it for reference and example purposes. Usually, you wouldn't keep it around. You can safely remove this if you want. Alright, next we'll need to update the global guard. We defined the global guard in the router file. Currently, we're logging a message. Let's update the log statement to log a property called to.meta. The to object represents the route the user is navigating to. We're accessing a property called meta. The meta property is an object of metadata attached to a record. If metadata does not exist on the route record, the value will be an empty object. To better understand, let's check out what's inside. Refresh the page in the browser. In the console, we'll find the metadata from our route. We want to check if any of the matched records have the requiresAuth meta field. If any of them do, we will want to check if the user is authenticated. Let's get started. Back in the editor, we're going to comment out the log statement in the global guard function. The first step we'll take is to check for the meta field. There isn't a point in checking if the user is authenticated if the route is accessible to anyone. We're writing the logic in a global guard. It's important that we don't assume anything. We'll create a conditional block. We will want to check if the requiresAuth meta field is present in the records that match the path the user is navigating to. Inside the condition, we're going to check the to.meta.requiresAuth property with the not operator. If the record does not have this meta field, it doesn't require authentication. We'll let the user proceed by calling the next function. The next function doesn't end the function. We'll want to return the function before moving on to the next step. If the condition ends up not passing, we know that the route does require authentication. This means we should check the store for the user's authentication status. First, we need the store. At the top of the router file, import the user store. Go back to the navigation guard. After the conditional block, create a variable called store. The value for this variable will be the store function. The store is now accessible from within the guard. Add a second conditional statement. The condition will check if the store.userLoggedIn property is true. If they are logged in, we'll let them proceed by calling the next function inside the conditional block. If they aren't logged in, we'll need to redirect them to the home page. Let's create an else block. Inside the else block, we'll call the next function. We'll pass in an object with the name property set to home. We're using the same logic we used in the manage component for redirecting the user. The main difference is that this will run on any record that has the requires auth meta field. Let's check if this solution works. Refresh the home page. The page will load normally. Next, let's try logging in and navigate to the Manage page. The Manage page is working fine. We can view the route history to make sure nothing funny is going on. It's always a good idea to keep an eye on this. If any of the records have the requires auth property, we will proceed to check if the user is authenticated. If they aren't, we will redirect them to the home page. Otherwise, we'll let them proceed onto their destination. This behavior is possible thanks to route meta fields. By assigning custom values, we can write more flexible code for our application.